Imagine an object so powerful that nothing can escape it, not even light. These mysterious objects are called black holes, and they are some of the most fascinating things in the universe. But what exactly is a black hole, and how does it work? Let's find out. A black hole forms when a very massive star reaches the end of its life. Throughout its lifetime, a star balances two forces. Gravity tries to pull all the star's matter inward, while energy from nuclear fusion pushes outward. When the star runs out of fuel, the outward pressure disappears. Gravity wins, causing the star's core to collapse. If the core is massive enough, it becomes compressed into an incredibly small region of space with an enormous amount of mass packed inside. This creates a black hole. The gravity around a black hole is so strong because a huge amount of mass is squeezed into a tiny area. According to the theory of relativity developed by Albert Einstein, massive objects bend the fabric of space and time. A black hole bends space-time more dramatically than anything else we know. Surrounding every black hole is an invisible boundary called the event horizon. Think of it as a point of no return. If anything crosses the event horizon, it cannot escape the black hole's gravitational pull. Even light, which normally travels at the fastest speed possible, cannot escape once it passes this boundary. That's why black holes appear completely dark. At the center of a black hole is what scientists call a singularity. This is a point where matter is crushed into an extremely tiny space, and our current understanding of physics breaks down. We don't yet know exactly what happens there. You might wonder, if black holes trap light, how do we know they exist? The answer is that we observe their effects on nearby objects. Black holes can pull gas, dust, and even stars toward them. As this material spirals inward, it forms a hot, glowing disk called an accretion disk. The material becomes so hot that it emits powerful radiation that telescopes can detect. Scientists can also observe stars orbiting around invisible objects with tremendous mass. By studying these motions, they can determine that a black hole must be present. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow, providing direct visual evidence of these extraordinary objects. Not all black holes are the same. Stellar black holes form from collapsing stars and can contain several times the mass of our sun. Supermassive black holes, however, are millions or even billions of times more massive and are found at the centers of most galaxies, including our own galaxy, the Milky Way. A common misconception is that black holes act like giant cosmic vacuum cleaners sucking everything in. In reality, if the sun were somehow replaced by a black hole with the same mass, Earth would continue orbiting it just as it does now. The black hole's gravity would be the same at that distance. The difference is that it would no longer provide light or heat. Black holes also slowly lose energy through a process called Hawking radiation proposed by Stephen Hawking. Over incredibly long periods of time, this means black holes may eventually evaporate. So black holes are regions of space where gravity becomes so powerful that nothing can escape beyond the event horizon. They form from collapsing massive stars, warp space and time, and help scientists explore some of the deepest mysteries of the universe. The more we learn about black holes, the more they challenge our understanding of physics, space, and reality itself.
If you liked this video, remember to like and subscribe to see a cool animation and help us on our journey. Thank you.